So this is Geometry Semester 1. It's the 5th unit called Pythagorean Theorem. It's the 3rd lesson called Solving for Legs and Hypotenuse Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the site. It says for directions, copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So I always try to model this for you just so you can know what I'm trying to communicate here. So this is creatormath.weebly.com. That's the site. Here's the home page. Here's what it looks like when you get to the home page. If you scroll down, you're going to find everything you need to know about the composition book, the requirements, the videos that you need to watch to do it, the due dates, etc. We're going to go to Notes for Geometry. That's all under the Geometry tab. There's vocabulary. This is the entire PDF for vocabulary for the full year. You can look up all vocab words on there. If you're not getting 100% on your vocab practices, then you don't know about this PDF and you may not know how to search it. All right, Google it, open it up, find it, and I'm going to leave that to you for now. Let's go to the right semester. Make sure you're in the right semester. Okay. See if I am. Okay, I'm not. There we go. Okay. For this particular lesson in semester 1, it's the table of contents. You need to know exactly where it is. This entire table of contents should have already been copied into pages 2 through 6 of your composition book. If you have not done so, please stop what you're doing right now and copy it in. If you haven't numbered your pages, please follow the video on this website, creatormath.com, on how to number the pages of your comp book. Every page number needs to be numbered correctly, and therefore you can go through and start to put in the content according to where it goes. That way when I grade it, it doesn't drive me insane trying to figure out where you've got everything, right? So this is the unit on Pythagorean Theorem. This is the 5th lesson, I think. Which one is this? Oh, the 3rd lesson. So let's go to number 3 right here, solving for legs and hypotenuse. Here's the page numbers that the notes go on in your comp book. Here are the notes. We're going to open them in 1 second. Please don't take these page numbers on this video for what it really is. Look up the actual table of contents on the website at the time you're watching this. By the time you watch this, it probably will be different. We're going to click notes. Sometimes I have to click them twice for them to load from the website. There they go. It loaded the first time. You'll be able to expand it, and you'll be able to put in these notes on the Pythagorean Theorem solving for hypotenuse and legs. So here's a right triangle. That's what we use with the Pythagorean Theorem. Here's the Pythagorean Theorem. Hype squared equals leg squared plus leg squared. If that doesn't look familiar, go back and do the other lessons first. This is lesson number 3, so we're going to move through it a little bit quicker. We're plugging in hypotenuse here, 7 squared, 5 squared is a leg, and x squared for the missing leg. We're solving for that, and we're going to do a bunch of problems like that, so I'm not going to go over too deep into it here, but just let you know there are several problems. You're copying into your notes. You're trying to understand what type of triangle is this. Is it right, acute, or obtuse? By setting up the Pythagorean and leaving a circle. If the hypotenuse is larger, this becomes an obtuse triangle. Obtuse because the hypotenuse is longer than it should be. See that? So it looks like an obtuse triangle. It might be a little bit bigger for you. There you go. And what's this one? In this case, the legs are bigger, right? So this becomes, it's acute because the 2 legs are longer than they should be. And therefore, it would have been nice if I had a little graphic of acute, but I don't. So we'll look at that as we go. Vocabulary is the Pythagorean Theorem. Perfect squares, 1, 4, 9, 16, etc. Go back and see prior lessons on that. Simplifying a radical, how to pull a perfect square out of a radical. Okay, there are sample problems you're putting into your notes and solving if you can. Otherwise, we're going to roll on the problem set for this and demonstrate these. So what is the Pythagorean Theorem? This is it right here. And remember, just from prior lessons, a lot of students learn a squared plus b squared equals c squared. It's a double-edged sword for me. I don't like it one way. I like it because students can remember it. It's sticky. They do remember it. What do you think the most common mistake is? They forget that this has to be the hype. C has to be the hypotenuse. So sometimes I'll have students write it this way, c squared equals a squared plus b squared, so at least they can focus on the hypotenuse first. But then I just stopped altogether with this a, b, and c stuff, you guys. Just leave it. Just go to hyp squared equals leg squared plus leg squared. And you'll see as we fill this in, it makes it much clearer for us to fill out the Pythagorean theorem correctly. The next one is, what is the hypotenuse? First of all, we spell it hypotenuse. That's how you spell it. We pronounce it hypotenuse in a right triangle. More than one answer may apply. It is the longest side, you guys, and it is the side across from the 90. It's not a side touching the 90. Those are the legs. It's not the side at the bottom. It's not the short side. Side across from the smallest angle, no. Two answers. Longest side, side across from the 90, which is the largest angle in the triangle. This is a leg. This is a leg because it touches the 90. And this is the hyp. And I'm going to abbreviate hypotenuse hyp because it is not touching the 90. See how the 90 is over here? All right. What is the leg in a right triangle? And we already did that in the graphic above. It's either of the two sides touching the right angle. Nope, it's not the longest side. Nope, it's not the side from across from the largest angle. All right, name the sides in the triangle. So let's do some practice. Is it touching the 90? Then it's a leg and a leg. A right triangle or a triangle has two legs like a human. That's the easiest way I can get you to remember it. Remember it that way. The one not touching the 90 is the hyp. Okay, so B is a leg. Here's B is a leg. A is a leg. A is a leg. And C is a hypotenuse. It's this one here. I'm going to move rather quickly because this is a repeat from the prior two lessons. It's warming us up on how to fill in this Pythagorean theorem correctly. All right, name the sides. What's touching the 90? The leg and the leg. Two legs like a human. What's not touching the 90? The hyp. So the hypotenuse is A, the leg is B, and the leg is B. Done. Three sides, two legs, and a hypotenuse. This is the hyp. Why? It's not touching the 90. Okay, 90's here. And I know it's on a Cartesian coordinate system, but we can see that this is the origin. This goes out on the x. This goes out on the y. This has got to be a 90. Since these touch the 90, they're leg and leg. A is a leg. So, A is a leg. A is a leg. B is a hypotenuse, and C is a leg. I like this answer. I got to check this because it should be up in the A position for me. Remember, all my answers are up in the A position, and yours should be mixed and random. So A leg, C leg. A leg, C leg, B hypotenuse. I like this answer. I'll go back and look at that before you get to it. All right, given the following, we're going to fill out the Pythagorean theorem now. So let's do hyp squared equals leg squared plus leg squared. Please do it this way. A, B, and C is going to drive you nuts because I know you're going to mix up the ABC if you're like typical students, which some of you aren't, but some of you are. So let's deal with the hypotenuse first. Not touching the 90 is 13. I got 13 squared equals 12 squared is a leg. Why? It's touching the 90. And there's an x squared, and there's a plus in here. So these can be reversed, right? You can add 3 plus 5 and get 8, or you can add 5 plus 3 and get 8. You can reverse anything added according to the properties of math and get the same number, and we can just prove it right here. So we're looking for 13 squared equals x squared plus 12 squared. Yes, that would be a reverse, and 12 squared plus x squared. You can reverse these two, and both are correct answers. All right, same thing, let's set it up. Let's do hyp squared equals leg squared plus leg squared. This is an x, not touching, so it's the hyp. X squared equals, this is a leg, touching the 90, touching the 90. 15 squared plus 8 squared. Here's an x squared equals 15 squared plus 8 squared. Here's an x squared equals 8 squared plus 15 squared. You can reverse the two legs. That's why there's no designation of leg 1, leg 2. There is no such thing. Either leg goes in either position. Both are acceptable. Both will solve the same way. All right, hyp. Okay, I can't write hyp. Hy P squared equals leg squared plus leg squared. All right, height. It's an x because it's not touching the 90, right? So you got an x squared equals a 12 and a 5. 12 squared plus 5 squared. Let's check this one. 12 squared plus 5 squared equals x squared. 5 squared plus 12 squared equals x squared. Either of those answers, we're going to mark them both. More than one answer may apply. Given the following right triangle, solve for the missing side. Woohoo! Here we go. All right, finally we get to do a problem. Height squared equals leg squared plus leg squared. Height squared is x, so x squared equals 12 and 5. This is one we already did, so we're setting it up the same way. We're going to take the square root of this side and the square root of this side, and that's going to give us straight x here. And we might as well, let's see how easy this becomes. Maybe I'll do it this way, maybe not. Let's rotate our calculator. And let's go back to where we can see it all. Let's clear this out, and let's say square root of 12 caret squared plus 5 squared. 13, you guys. Doing the whole thing right there. It's the square root of 12 squared plus 5 squared. We just typed the whole thing in. It's 13. Right? Don't do it in pieces. Don't put 144 plus 25 and then take the square root. I mean, you can if you want, but all right, you can if you want, and I should probably show you that, right? This would equal x equals square root of 144 plus 25. 144 plus 25 is x equals square root of 169. If you know the perfect square root of 169, it's 13. Now, in algebra, you put a plus minus in here. Why do you not put a plus minus in here in geometry? Why? The answer is there's no such thing as a negative 13 side length. This doesn't exist with a physical shape. You can't have a side length that's a negative length in geometry, because negative denotes direction, not some sort of dimensional aspect, right? So we can't have a negative length. So you only have one. You only have the positive answer to this. Kind of cool, huh? Why do you have plus minus in algebra? Why do you not have why do you just have plus in geometry? It's a physical shape. There is no such thing as a minus side length. Okay, so set it up. Oh, we're back to a setup. Fine. Height squared equals leg squared plus leg squared. Height squared is 7, not touching. 7 squared equals 5 squared plus x squared. Okay? And that's it here. 7 squared equals 5 squared plus x squared. 7 squared equals x squared plus 5 squared. These can be reversed. Now, do they want us to go ahead for the following triangle, solve for the missing? So let's keep this up. They're giving us the same triangle here, and just saying solve for the missing side. So we're just going to rewrite 7 squared equals 5 squared plus x squared, since they already made us set it up, right? So this one takes some algebraic manipulation. We're going to remove the 5 squared from the right of this thing. Gone. Shows up here. 7 squared minus 5 squared. Now shows up right here as a minus 5 squared. Down comes the x squared. The equal stays in. Now we take the square root of this side and the square root of this side. That's going to give us x equals the square root of 7 squared minus 5 squared. Take note, this is now a minus, right? So I'm going to go straight to my calculator like I did before. And I'm just going to do 7 squared minus 5 squared. I'm just going to manipulate this and do 7 squared. I'm going to make sure this says minus, and it already says 5 squared already. Oh, okay, nice. All right, let's do this. X equals square root. I should look at my answer choices. 49 minus 25. X equals 49 minus 25, right? 24. All right. This is not simplified. Does it say that? It doesn't say simplified necessary. Let's look a little bit closer to this. We've got a square root of 24. The question is, can you go ahead and go with this answer? You can't, because this is actually square root of 4 times 6. The square root of 4 is a perfect square 2, which equals 2 square root of 6. The 4 comes out of the square root symbol, the 6 stays under because it has no perfect squares left in it. So the correct answer of this is 2 square root of 6. All right, I like this one best because it's simplified. This is not a simplified answer. It would be like putting 2 over 6 into your answer, and that's not correct. You want to put in 1/3. You want to simplify in math before your final answer, right? Given the following, solve for the missing side. All right. Well, we know this is hypotenuse, right? So we got x squared and a leg. 6 squared plus 10 squared. Yeah, I'm cutting corners, you guys. Look at that. Hypotenuse squared equals leg squared plus leg squared. Let's take square root of both sides. And we got x equals square root of 36 plus 100. That's 136. 136. All right, what is inside of 136? I have a 34 in here. Is there a 4 in there? So literally what happens with me, right, and I encourage students to do it this way, and I'm going to model it for you. Let's figure out this 136, right? Let's clear it and say 136 divided by 4. Yes, there are 4 times 34 inside 136. All right, so I know we can pull a 4 out. Are there any other perfect squares inside of 34? Is there a 4 in there, for example? 4 times something equals 34? No. Is there a 9? 9 times something equals 34? No. Is there a 16? 16 times something equals 34? No. All right, why am I going through those numbers? Because those are the perfect squares I'm trying to pull out. So this becomes x equals 4 times 34. And I had a little bit of a hint here, you guys. I'm looking at the answer choices, right? So x equals, this comes out as a 2. And this stays under as a 34. Whoops. So sorry. So sorry, so sorry. So go through that again real quick. This is 4 times 34 is 136. And the 4 is a perfect square, so the square root of 4. You could have written square root of 4 times square root of 34. And therefore this comes out as a 2, because square root of 4 is 2, and 34 stays under. Right? So it's this one here. And I want to make sure that's right too. There it is, 2 times the square root of 34. This is the square root symbol in the computer that you got to get used to. All right, given the following triangle, what type of triangle is it? Aha, this is great. So now they're giving you all the sides. So let's do height squared equals, no, height squared circle, leg squared, plus leg squared. All right, circle, because we don't know what it is yet. 17 squared, circle, leg squared, plus leg squared, right? Circle, 289. Just type it in your calculator if you don't know. It's on the top of my head. I got to memorize. 289 is 17 squared. 144 you probably do know, and you definitely probably know 100 here. So 289 circle 244. Which one's greater? The height is greater. So the height is stretching out, and the 2 legs are stretching to meet it. This becomes obtuse, which means greater than 90 degrees. This is an obtuse triangle. So 289 is greater than 244, obtuse triangle. Love those. Those are cool. Okay. One more, and it's the same type problem. I think these are both the ones in the notes, by the way, so look them up in the notes, plus you got the solution here. Height squared equals leg squared plus leg squared. Height is 16, not touching the 90, right? So 16 squared equals, no. Circle, okay? Circle, leg squared, 12 squared plus 11 squared. 16 squared is 256. Go ahead and type it in if you don't know, right? 16 squared, 256. 144 plus 121. Circle, 256. 265. 265. 5, 6, 2. Okay, so 265. Which one's bigger? The legs are bigger. So what you have now are the legs pushing out like this, and the hypotenuse, right here, starting to form an acute angle. What's an acute angle? It's less than 90 degrees. So 256 is less than 265. Acute angle. What if it came out that this happened to be equal? Then what is it? Then it's going to be a right triangle, right? Because it would have to be equal for Pythagorean to work. It has to be a right triangle. So if we got equal, and it would be nice to have one more example of that, but we don't. So just get it in your mind, and maybe I've got it somewhere else. I'm not sure. Make sure you're matching up the title for these, you guys. So the practice set you're doing matches up with the video you're watching. This is Geometry, Semester 1. It's the 5th unit called Pythagorean Theorem, and the 3rd lesson called Solving for Legs and Hypotenuse Practice, right? It's on creatormath.com under the Geometry tab. Hope this helps.